Hey, let me introduce you first. Automate Cura. This is the home-state manufacturing software for um, different type of desktop visual and fabrication 3D printers. And it's not complicated, the software. As you see here, I set this machine. You can manage the type of printer you have, or if you don't have a printer, you can set actually printer as Ultimaker 3 extended so that we can easily make use of our 3D printer, which is available in our lab. Make sure that you set this machine. I think that should be somewhere here. Yes, printer. And again, you can add printer, same side. Yes, here we go. There are, as you see, different say type of 3D printers available. I have Ultimaker 3. I set it to Ultimaker 3 extended. But since it's already added, I'm not going to add a new one that is already added, and this is the evaluation of our printer. So I don't want to do any more printers. And what I do, by default, you should have some type of nozzles here. In Ultimaker 3, we have two nozzles, two extrusion head, I can say. And the print core size is a 0.4. Make sure that that is correct. And then we'll probably be using PLA material. We have Ultimaker PLA. The color is not important, but right now I have set it to red. And I will not be using the secondary extruder, so you can disable it. Right now, just the first one is enabled. Then we have here some settings. This right-hand side, you can see that there are various options, but right now I set it to fine printing with the layer thickness of 100 micrometers. Now the thing is that in order to actually generate an example Gcode file and then later work on it, it's better to design and kind of a part which is going to be somehow similar to your goal. As you know, in this project, you're about to manufacture or design such kind of shell-like structures. You will have a kind of a polygon, and that will be line. So that's an example, a simple example, which we can produce with the same project. So I have designed a kind of a rectangle square, and there is a line passing through square, and I set the thickness to actually 0.4, which is the nozzle diameter of our 3D printer. This thickness of the STL file is 0.4. So how do I export this design? Let me remove it and then once again. So you from here you call an STL file, you import it. Depending on your settings, this Cura software to perform some slicing. And as you see, the height of the model is not too much, since my goal is to check the Gcode file, the content of it, and then later use some principles of it to generate other Gcode files on my own. So that's why I keep it a bit shorter, and the edges are not complicated, as you see, straight edges in X and Y axis, since I will be determining the extrusion rate from these, let's say, G-codes. So that's why I keep it as simple as possible. Now let's have a look at the settings. It's better we go with a layer thickness of 0.1, fine printing case. So that's why I set the 0.1. Let's start with this. Okay. Now let's go through each settings one by one. The quality is mostly about the layer height. If you increase the layer height, your overall quality will be decreased. We are keeping it as equal to 0.1. And this right now, in our case, the shell is not important, but depending on your task, you may play with this one. But even though I increase this one, let's say to 10, there will be no change in the Gcode file or the trajectory. Now let's focus on to, I will disable this iteration. Now, since it's a 2.5D part, as you see, all the layers are the same. Just the first layer is a bit different. Now let's have a look at how this layer is printed. One rectangle here, another rectangle here. Then it passes through these two rectangles. Since the thickness of this intermediate part is a bit higher than the thickness of the left and the right parts. And the shell thickness or wall thickness or the number of shells determines how many walls are you going to have. But since the thickness of the walls right now is equal to 0.4, so we cannot have more than one actually wall. But obviously at the center, since the thickness is a bit higher, but as far as I remember, 1 millimeter, that's why we have 3, as you see, or I'm not sure. Yeah, we have 3, as you see, shells, but for the left, right, and top and bottom sides, we only have a single shell. And I'm repeating again, since the thickness is equal to 0.4. That's how I designed this model in CAD software and then saved as an STL file and later imported into this Tura software. Now, this is, you can do some simulations. This is a simulation on the same layer, and this is a simulation between the layers, okay? And this blue one is actually representing the past motions. Now let me again switch to the top view. And from, we are not at the preparation, let's say, tab. This preparation, you see the CAD model, but in the preview tab, you see the layers, the deposited material. And in the monitor tab, if your print is connected to your network, and you can check the position of the extruder or see the, let's say, process going on. Since there's a camera installed on this printer, you can watch your printing actually in a live manner. But our main focus will be on preview right now. And here, layer view, yes, material color. As you see, travels is marked, so that's why actually we see such past travels. At the beginning, in the first layer, the extruder head is at this position, then it performs a pass motion, goes that point, and then starts depositing. So if I disable it, I'm not going to see any past travels, just the travel of the extruder one is visible. And since we don't have an infill, so it will not impact us. But depending on the complexity of your part, sometimes you will always have some infill patterns. But I want to discuss the past travels. That's why I'm going to enable it. Now let me focus on an intermediate layer. So what is on here? So 2 edges are printed, 3, 4. Now 4 edges are printed. Then what is done? As you see, there's a fast motion. I'm sorry. There's a fast motion between this point and the next point. Now you will see that when I click my arrows on the keyboard, there will be a blue line. Yep, you see there's a blue line. It means that while this motion, no material is deposited, it's just the head is just moving from left to right. Okay, and then what is being done? Now we will be performing an extrusion, as you see. For that, there is no red line. Now, if I click on my keyboard, there is a red line, meaning that some material is deposited on this line. Another line, another one. And performs, I think, little motions here. Another fast travel, no printing. So there are some fast travels. I'm clicking on it, and it's passing through edges once again. So this is up to you actually. Depends on your type of deposition. And the thing is that the main philosophy is that it's better you don't perform any fast travels. If you do so, manufacturing time will be decreased and the quality of your manufacturing will be better. So that's why, if it's possible, you should always avoid using fast travels, which means actually using G0 commands. Without deposition, the head is moving from right to left from one point to another point. And this is actually how manufacturing is performed. Since the sun, as I said, 2.5D shape is performing the same operations on top of each other. And the thing about this fast travels is that, let me focus on here again. Yeah. So if you stop, extrusion, then that means the material actually should be retracted. So during the printing, this white material is at the tip of the nozzle, it's depositing. But once you want to do actually a fast travel, then you should retract this white material so that it will not be deposited on the table or on the layer, and with the help of it, you can move to the next point. And when you come to the beginning of the next line, next deposition line, then you should restart extrusion so that you push this material a little bit more and then continue with depositing again. So that's why this fast travels are important. And let's focus on more about these variables here. I discussed the quality, shell. Right now, our focus is not on the infill pattern, so I'm not going to discuss, but maybe in your upcoming projects, if you are going to fill the interior, you may have a look at it here. You can change the infill percentage, the type of infill patterns. And we have a material part. This is about the printing temperature and the temperature of the base plate. You can keep them as it is, 360 degrees for the base plate, and the speed of printing. And you see we have two different speeds. One speed is for deposition, and the second one is for fast travels. As you see, it's about 4 times the deposition speed. And especially you don't change actually these parameters. And we need to have retraction that is enabled. You need to have cooling, and support structure is not important for right now since our part is 2.5D. It doesn't require any support structure. We don't have any inclined surfaces, so you can disable it. Then we have view plate aeration. If you remember, I said that the sticking actually to the base plate is highly important. If your part is not stick to the base plate, then you will not be able to have proper prints. Maybe at some point, if you'll be removed from the table, the quality will be lower. So sometimes, in order to increase this aeration, you may go with, let's say, brim. What is brim now is going to do slicing once again, and you'll see that at the base, we have an extra, let's say, material on the outer profile. So with the help of it, our part will have more connection to the base plate. But if you don't have it, then our part will be connected to the base just on these edges. And if you increase it, then probably the quality will be improved. So it's better actually you have some amount of brim around your product, but it's not a must. Since if you want to have such brim, then this may increase the complexity of your coating. Why is that? Since you have an outer boundary and you need to take offsets around that boundary, and you need to generate more, let's say, lines, more comments in the Gcode file. So that's why I suggest you don't work with brim in this project, but just go with none option so that we will only have edges on the base plate. There's a little weird thing here, but not important. As you see in the first layer, these parts are not deposited, but it's just working on the intermediate part. It's probably due to maybe a little bit inclination of the part, or it's trying to make actually the intermediate part more stable, I guess. But this is not important. You should always have the same pattern at each layer. Don't have different patterns for different regions of your product. So you should be working on such a layer all the time, starting from the first layer up to the last layer. And we have dual extrusion, but these are not important right now. They are not actually enabled. So these are, I can say, about parameters. So what I'm going to do right now is to generate this Gcode file. Now everything is set. I can save this file as a, let's say, Gcode file. Let me save it into my Dropbox account. Yes. Now I will show you the generated Gcode file. So you see you don't see, but I will now show it to you. Yes. I guess now you see the Gcode file. So as you see, the file format is simply Gcode, and you can open it by using any text editor. And if you remember in the lecture, I said that there are mainly 3 parts in the Gcode file. So up to this point, it's a key kind of a header of the Gcode file. And by the way, if you use such semicolon, then that means actually these are comments for the firmware on the printer. It's just giving some extra information regarding your file, regarding your print. So what do we have it inside? The type of Gcode we are using, type of engine we use for slicing, type of machine we are using, the temperature of the extruder, the amount of material we are going to use is calculated, and the type of material we are using. This is actually kind of a serial number for the material, not important. The nozzle diameter, the type of nozzle we are using, the wheel plate type, the temperature of the wheel plate. So there are many information. The size of our wheel plate machine. These are all for actually giving extra information. Then actually starts the main code. As you see right now, we don't have any semicolons. They are just comments, G codes, M codes, and we have, or let me show you first. We have some initial comments regarding that. We are using the first extruder. We are using the absolute extrusion mode. And then we are setting the temperature of the extruder. And then we start with the first layer. It's actually named as 0th layer, but nothing different. It's just about the first layer we see in the Cura software. And as you see here, the Z height is set to 0.27. So it's better you also start at this value. And I will later show you some other things, but let me show you. Yes. Now we are switching to the second layer, next layer, and before that, as you see, this Z value is increased by 0.1. And for that purpose, we use G0 command. If you remember, this is a fast travel motion. Since while moving from one layer to the next layer, you're not going to print anything. We are simply switching the planes, and that's why we can use G0. But the thing is that we are not doing it at a high speed. The feed rates for that motion in Z motion is 600. But if you are moving on the XY plane, as you see, we don't have a Z command here. And you can see that the feed rate is much higher for this fast travel on this plane with regard to the fast travel in the Z-axis. And then it's moving somewhere. This goes like that. As you see, I will show you some point. This is layer 2, as you see. And again, these are comments. You don't need to have such comments, but if you want to actually parse your Gcode, sometimes it's better you add such extra lines, but it's not a must. Now I'll jump to last part of this Gcode file. Yeah, I think that is here. Around here, actually, the printing is over. It's doing some retraction, and then it is actually setting the temperatures to lower values. It's wiping the material around your spool. It's doing some more retraction, disabling all the actually stepper drives, and then setting this temperature to 0, as you see here. And this is the end of the Gcode file. And it's better you'll have the same end part in your generated Gcode files and the same header part for your, once again, generated Gcode file. So you should be working on just the intermediate part. Header and the end part should be the same, and your Python script should be modifying the interior, the middle part of this Gcode file. And another thing I want to talk about the interior is that let's focus on some comments here. So it's better you check sometimes what is the meaning of a single comment. Let me share you the set of comments. So you can simply go to this website, marlinfirmware.org, and then you can switch to the Gcode files. And here you see we have the list of all Gcode files and mcode. And obviously, I don't remember all of them. I just remember some basic ones. But let me go back to the Gcode file once again. For instance, we have some special comments like M204 and 205. Let me share it with you once again. So let's check M204. It's about starting the acceleration and doing some actually retraction. That is for removing the material from the tip of the extruder so that you can perform some fast travels. Let's go back to the Gcode file once again. And as you see at this point, we are setting the Z height, or I can maybe jump to somewhere here. Yeah. So let's focus on here on this point. We are doing a kind of an extrusion in between these two comments. Just this one is meaning that the extruder head should move to this X value and Y value, and while it's moving from the previous X and Y value, Y point, it should be depositing this amount of material. Actually, the difference between this E value and the next E value. So this is a kind of a relative coordinate, I can say, and we will be depositing about 0.5 millimeter of material during this motion from the first point to the next point. Then in this comment, actually what we are doing a similar deposition. We are going from this one to the second point, and as you see, X values are the same, just the Y values are different, so it's actually moving, doing a vertical motion. Just Y-axis is different, and as you see, we are depositing about 0.36 millimeters of material. So you have this difference value between two E values, and you can also take the difference, the delta Y, and try to come up with a ratio. So how much material is deposited while moving, let's say, 10 millimeters on the Y-axis. That will be your kind of an extrusion ratio, and then you can use this extrusion ratio in your Python script to come up with your E values. And then what is done after this is printed, we do some retraction. We are retracting the material, and then we are doing a fast travel motion, and we are again changing our, actually depositing some more material to here. I don't know where, but it's kind of doing switching the mode of deposition, and then performs another deposition. Then next we switch the layers. We are moving to the next layer, and as I said, at a slower speed this time. And later in the next layer, we are going to a specific point at a faster manner. And this continues, this movement continues on this layer. And we are now trying to print, starting to print the next layer. And some of these are related with the fan speeds. At the beginning of your prints, at the first layer, usually the fan speed is set to 0 so that material will be sticking to the base plate properly. And then at the first layer, the speed of the fans are increased a little bit. Then we will see that in the next layer, the speed is increased to maybe 120, and maximum the speed of the fans can be 255. And some other parameters, and this is about restarting the deposition. So With the help of these, we were doing retraction, and now we are restarting the deposition. And as you see, the feed rate is set, and the same amount of material is actually called once again. And later, we start again depositing with the help of these commands, and it goes like this. So this is actually repeating the same motions all the time until all the layers are fabricated. So how we can make use of this information? Now let me switch to the Python codes I have written maybe 2 years ago, something like that. Yeah, not complicated. I will show you. Yes, this is in about 30 lines, so you can handle this thing. But the thing here is that I have already generated the trajectories using MATLAB, and the trajectories are stored inside a mat file. But you don't have to do this, and since you need to do them in the Python script, so this is not must for you, and you shouldn't do it. So what I do, let me try to increase the size of this view. Increase the size. Writing is here. Format. I couldn't find it. Okay. Then I first open a kind of a file. As you see, the format of the file is Gcode. I given a temporary name for that, and obviously I'm writing some things into this file, so W should be set. And in this example, my layer thickness was about 0.1, and the initial value of my Z is 0.2. And then I have an extrusion ratio of 0.04. I obtain it by, as I showed you a moment ago, by checking the delta X or Y and checking the delta E values. It's up to you, and this is not important. It's for my specific task. And then what I do, I write the initial part. As you see, you don't need to do it right like this one. You may read this header from a separate file and then write the same content into this new file. It's up to you. And then this main actual layers are printed with the help of this nested for loop. So what I do here, I check the trajectories inside my mat file. They are already stored in this mat file with the help of MATLAB functions. But as I said, you can easily do it in this Python script. And then at each layer, what I do, I try to get the lines which are to be printed. For each segment in the layer, I check the length of the segments, but it's up to you. You don't need to do this one. And then you may simply write a G0 comment so that you will go to the starting point of that line. And then this might be a bit different, but in the earlier days, Cura was using a special command for retraction and restart. It was G11, but right now it's a bit different. So you need to always update them. And then what I do here, I calculate the distance between the points. And then I simply determine the extrusion value, the E value, E axis value in my comments. So how I do it, I simply multiply the distance I just calculated with the extruder ratio. And I add it to the extruder position. Since it's an absolute value, I need to always sum on top of this extruder position value. And then later what I do, I simply write G1 comments. X, Y, and E value, they are already set. So this is it's not going to be the same in your script probably. It's up to your coding. But the idea is that you should always be writing G1 comments for the lines to be printed, and you need to be writing G0 comments for the fast travel motions. So once the layer is actually over, Then you can write the number of next layer. It's, as you see, a comment line is determining, is actually writing the number of the next layer. And then I simply increase the Z value. And at the top of the next layer, as you see, I have a fast travel motion, and that also has a Z value. And I do it until all these layers are fabricated. And lastly, I write the last part of the Gcode file again from reading another file, or if it's not complicated, you can simply paste it here, and without dealing with a new file, you can simply write these lines to the end of your Gcode file. So that is how you can generate a Gcode file for your models for your projects.